In this video, we'll prep for exponential and logarithmic equations just by looking at a couple examples to help review solving some basic equations. Now let's look at these two types of equations. The first one is, so we're to solve the following equations, where the first one is the quantity x plus 2 times the quantity x minus 3 equals to 14. So this is a quadratic equation where we got to do some simplifying first before using some of the basic techniques. So the first thing you would do is maybe multiply the two binomials together by like folding it out, or so you'd have x times x, so that'd be x squared, minus 3x plus 2x, so that'll be minus x, and then 2 times negative 3, so minus 6 equals to 14. And then to solve quadratic equations, usually what you want to do is to get 0 on one side, everything else onto the other side. So let's subtract 14 from both sides of the equation. So we'd have x squared minus x minus 20 equals to 0. And then we would first see, can we factor? And then if not, we'd use the quadratic formula. So this one does factor, so we'd have x minus 5 times x plus 4 equals to 0. So we have x minus 5 times x plus 4 equal to 0. So using the zero product property, either the x minus 5 is 0 or the x plus 4 is 0. And then solving those separately, we'd have x is 5 or x equals to negative 4. So those would be the solutions to that quadratic equation. Now, just to show you how this relates to solving some logarithmic equations, what we may see is something like this. If we had, let's say, the natural log of x plus 2 plus the natural log of x minus 3 equals to the natural log of 14. Using the product rule of logarithms, we could combine the two logarithms on the left hand side together. So we'd have natural log of x plus 2 times x minus 3 equals to the natural log of 14. And then if we had these two single logarithms equal to each other, where the base of the logarithms are the same, which it's base e because they're both natural logarithms, then what's inside the two logarithms are equal to each other. So we could say that this means that x plus 2 times x minus 3 equals to 14. And if you notice, that's the equation we just solved. So we would then do like what we just did to solve for x. Now, one thing to note, and this is really giving you a preview, is that we couldn't have negative 4 as a solution, because if we plugged in negative 4 into the logarithms, we'd have, let's say for the first log, we'd have natural log of negative 4 plus 2, so that would be the natural log of negative 2. And if you remember, you cannot take the logarithm of a negative value. So it turns out that that negative 4 would be what's known as an extraneous solution. But again, that's a preview ahead. Now looking at this other equation, this rational equation, we have x plus 1 over x minus 2 equals to 2. So to solve this equation, one thing we could do is to multiply both sides by 2. Sorry, not by 2. Both sides by x minus 2. So, minus. So multiplying the left side by x minus 2, the right side by x minus 2. So on the left-hand side, the x minus 2's cancel. So you'd have x plus 1 equals to 2 times the quantity x minus 2. Distribute that 2 on the right, so you'd have on the right hand side 2x minus 4 equals to, on the left hand side, x plus 1. Subtract x from both sides, so you'd have on the right hand side x, add 4 to both sides, so you get x equals to 5. So we have a solution to this, and we could check it. Plug in 5 into, for x, you'd have what? 5 plus 1, so that'd be 6 over 5 minus 2, which would be 3, which does equal to 2. Now again, to show you how this relates to what you're going to be doing is, again, what if we had, let's say, like I said, natural log of x plus 1 minus natural log of x minus 2 equals to the natural log of 2. So if we had this logarithmic equation, similar to what we just talked about for that previous one, we could combine the two logs on the left-hand side using the quotient rule for logarithms. And then if we have those two single logs equal to each other, then what's inside the logs would equal, and we'd end up with that equation we just solved, the x plus 1 over x minus 2 equals to 2. So you do have to remember some of your basic techniques to solving equations, because they may come up in your middle steps when you're solving exponential or logarithmic equations.